Negative resistance. Is that even possible? I always thought that if current passes through a resistor, it creates a positive voltage drop. The more current passes, the larger the voltage drop. So I wonder what happens with negative resistance.
Here is a simple circuit where a voltage source is in series with a resistor. The current flows out of the voltage source through the resistor. As the voltage source increases, the current flowing out of it will also increase. According to Ohm's law, as the current through the resistor increases, the voltage drop also increases. Here is a negative resistance converter. Everything in black is given, and what is written in blue is used for the calculations. Looking at the black, one might think that the current flows out of the voltage source through the resistor. However, that is not the case, and we will see it in the math that it acts contrary to Ohm's law. Because of the op-amp, the voltage at both the inverting and non-inverting is V. You can solve for I1 to find the current, which then you can find the voltage drop across this resistor and find V0. Once you know V0, you can find I2. Since current flows high to low voltage, the current is drawn and flowing to the left. Using Kirchhoff's laws, I plus I2 equals 0 because no current flows into the op-amp. Solving for I, you get I equals negative V over R, which means current is flowing back into the voltage source.
Oh boy, all that math sure is boring. Wouldn't it be nice to actually see how this works?
Here we have our circuit schematic drawn in PSpice, and it's very much the same as we saw previously when we were doing our calculations. But now in PSpice we'll be able to see the relationship between the varied voltage source and the current across this resistor. When we run the simulation, we can now see the reverse relationship between the voltage, this plot, and the current here. As the voltage is ramped up positive, we get a negative current across that resistor, and as the voltage goes into the negative region, we then get a positive current. This shows a reverse relationship, giving us the appearance of a negative resistance.
This is the setup we used in lab. Pictured here on the breadboard, you will see the simple circuit on the left, and over on the right will be the negative resistance circuit that we used. Here's a quick close-up of our simple circuit. Starting here, you have the voltage source, which goes through a resistor, which is also in series with another resistor, which then goes back to the ground, same as what our drawing was earlier. Pictured here is our circuit we built. Just like before, we have voltage in and ground. Using the op-amp and placing the resistors corresponding to the previous diagram, we're able to use LabVIEW and measure the negative resistance.
Here's our LabVIEW program where we have 3 DAC assistants, one to drive the voltage for both circuits, a second DAC assistant to collect information from standard circuit, and a third for the reverse resistance. The graphs that are running shows a Ohm's law and a reverse relationship in the reverse circuit. When it's finished, there will be a plot on the left showing by Ohm's law we get the resistance that's positive as the voltage goes up, and the right plot shows a negative resistance in the reverse resistance circuit. It actually worked! Can you believe it? I guess you can have negative resistance.